Hi everybody, this is Eduardo Suarez. This video is part 3 of a series of videos dedicated to iRPickTool. In part 2, we started creating a workcell using Roboguide HandlingTool. We added the two robots. We configured the user tool number 1 and user tool number 9. We added the infeed conveyors and the outfeed conveyors. We configured the tracking schedule on the conveyors, assigning encoder number 1 to the infeed conveyor and encoder number 2 to the outfeed conveyor. Finally, we assign the IP addresses for robot 1 and robot 2, and we consider that robot 1 is going to be the master robot controller. We're going to continue with the workcell configuration, and we're going to follow the iRPickTool setup workflow step by step. If we look at the workflow, on the previous video, we set the IP addresses for both robots. The next step is going to be setting up the RIPE ring. RIPE is an acronym that stands for ROS, Interface Packets over Ethernet, and also ROS is another acronym that stands for Real-Time Operating System. You would think that if we have a master and slave robots, you would start by setting up the master first, but in the case of the RIPE setup, it's the opposite way. We always start by setting up all the slave robots first, and at the end, we set up the master. I'm going to show you the way that you do on a real robot controller first, and then I'm going to show you the way you do in Roboguide. We're going to go back to Roboguide. We're going to select robot number 2, and we're going to open the teach pendant. Make sure that you have the teach pendant open for robot controller number 2. We're going to press menu. We're going to select setup. We're going to select host communication. We already set up the IP address. So now we need to select RIPE. This is ROS Ethernet Packets. And we're going to press detail. So here, this is going to be robot number 2 is going to be the slave. And if you look at the setup RIPE screen, it's showing the master. So we have to make sure that we select the slave. So over here, we're going to select slave. And you're going to see that this button changes from slave to master, and on the screen, it changes to slave. So we're going to look at the robot name. It's going to be robot number 2. The port, in our case, we are using the Ethernet port number 1. We need to leave it that way. The master IP address is going to be robot number 1. We need to change this one to 127.0.0.2, and automatically it changes to number 3. The member index 1 is going to be always a master, so this robot number 2 is going to have a member index number 2. If you keep adding more robots, you're going to increase the index by 1. And at this point, we need to press auto. And I cannot show you here how this is going to look like because we're in Roboguide, but I can show you some screenshots taken from the manual. So this is a screenshot taken from the iRPickTool operator manual. You're going to see in here that we are on the setup RIPE for the slave. We have the name of the robot, it's going to be number 2. In this example, they are using the port number 2. And we have the IP address for the master, and we have the IP address for the slave. And the number of members is 2. So at this point, we're going to press auto. The screen is going to change, and you're going to say repower after receiving data, and we're going to select yes. And at this point, the screen is going to change again. It's going to say waiting for data preview to cancel. And we're going to leave the slave in this state. And if you have more than one slave robo controller, you need to do exactly the same for all the other robo controllers until you finish with all the slaves. Now we're going to go back to the master robo controller. We're going to change the teach pendant to robo controller number 1. We're going to do exactly the same. We're going to press menu, setup, host communication. We're going to select ripe, and we're going to select details. In this case, this robo controller number 1 is going to be the master, so we have to make sure that it says master over here, otherwise you just invert by pressing slave on this selection over here. It's going to show the name of the robot. It's going to show the Ethernet port that we're using. This is port number 1. We need to select the IP address. The number of memory is going to be 2. And the update interval is going to be 400 milliseconds. This update interval is something similar to the request packet interval that we have in Rockwell PLC. It's saying how many milliseconds it's going to take for updating the data for the other robot controllers. If you find that the update is very slow, you can decrease this value, but by default it's showing 400 milliseconds. And we're going to leave it that way. So now at this point, again, I cannot show you how it's going to look like in Roboguide. We need to go back to the screenshots. This is a screenshot for the master. We're going to press auto again. It's going to say put all the slaves in auto mode. We're going to select continue. And it's going to say cycle power for setting to take effect. And we're going to select yes. And when we do that, all the slaves and the master are going to cycle power at the same time. If you're using the LMA robot controllers, this is going to be different. You have to cycle power each individual robot controller manually. And with this, we have completed the ring setup on the master and the slaves. So this is the way that you do in a real robot controller. I'm going to show you how this is going to be done in Roboguide. We're going to go back to Roboguide. We're going to select cell. We're going to select ripe setup. It's going to show a pop-up window. Over here, we're going to select the robot controller number 1. The host name is robot1, and it's showing the IP address. And we're going to select the robot controller number 2. That is, the host is robot2 with its own IP address. It's going to show again the update interval is 400 milliseconds, and we're going to press apply. And we can close the window. So this is the way that we have set up the ROS ring on Roboguide. And now it's just cycling power both robot controllers. After rebooting, we're going to select the robot controller number 1. We're going to press menu again. We're going to go to setup, host communication, ripe, details, and you're going to see here on the host name, it's going to show the list with robot number 1 and robot number 2 and their IP addresses. If you go to the robot controller number 2, it's going to show exactly the same list. One more thing that you can do to verify the communication between the two robots is working, immediately after cycle power, you can select menu, alarms, alarm log. We're going to select history, and you're going to see here that you're going to get the alarm RIPE-008 robot number 2 is online. If we select robot controller number 2, we're going to select menu, setup, host communication, RIPE detail is showing here in the list. And we're going to select menu, alarms, alarm log, history, and this case doesn't show anything. It's only on the master. And with this, we have finished with the configuration of the RIPE. We're going to go back to the iRPickTool setup workflow. The next step is setting up the encoders for the infeed and outfeed conveyor on the robot master and slave. First, we need to decide what type of encoder we're going to use. There are two types of encoders: the serial incremental encoder that is shown on the left and the incremental encoder that is shown on the right. In our case, we're going to use the one on the right. Next, we need to decide how we're going to connect the encoders to the robots. One way is using the line tracking interface, where we install the line tracking interface board to the master robot controller, as is shown in this diagram. The infeed and outfeed conveyor encoders are connected to the line tracking interface board, and using the right ring, we send the pulse counts to the robot slaves. Another way is using a multiplexer, where we have a line tracking interface installed on each robot controller, and we use an encoder multiplexer to send the pulse counts to each robot. In our case, we're going to go with the first option, where we have only one line interface board. In this diagram, you can see how the line interface board looks like. There are two options, the mini slot and the wide mini slot. All depends on the robot controller that you have. In the case of the LR-made robot controller, you need to use the mini slot, and you connect both encoders to the JRF3. In this diagram, you can see how you connect the infeed conveyor encoder and the outfeed conveyor encoder on the same connector on the JRF3. And if you have the wide mini slot, you have two connectors, the JF21 and the JF22, where you connect the infeed conveyor encoder to the JF21 and the outfeed conveyor encoder to the JF22. We're going to go back to the workcell, and we're going to configure the encoders. One thing to notice is that in order to use the Ethernet encoder, all the controllers connected to the right ring must have the same software revision. We're going to select the robot controller number 1, and we're going to open the teach pen. I'm going to split the screen. I'm going to select menu, setup, and encoders. Encoder number 1 is the one connected to the infeed conveyor. Make sure that you have the Ethernet encoder option R762 installed, otherwise you're not going to see the lines 10 and 11. So we're going to select encoder axis. Here you can select the encoder that you want to use. We are not going to change the encoder. It's encoder number 1. Encoder type, we're going to have the incremental encoder. We're going to go to encoder enable, and we're going to enable. You can change from on to off. Current count, we're going to change that. Average update, we're going to change that to 10. The 10 is the normal value that you use to smooth out the encoder. And then we're going to select line number 10, where we're going to enter the index for the master write ID. That's going to be 1. And the encoder master is going to be 1. Now we need to configure the outfeed conveyor encoder. So we're going to select encoder and we're going to type 2. The encoder axis is going to be 2. Encoder type is going to be incremental. Encoder label is going to be on. We're going to change the average to 10. We're going to select the internet master write ID. It's going to be 1. And the Ethernet master encoder is going to be 2. Now we need to cycle power in order to take effect. We're going to select function, next, and cycle power. Now we're going to select the robot controller number 2. We're going to split the screens. We're going to select menu, setup, encoders, and we're going to repeat the same process. It's going to be the encoder number 1 for the infeed. Encoder axis is going to be 1. Encoder enable, the average value is going to be 10. The Ethernet master write ID is going to be 1. And the Ethernet master encoder is going to be 1. We want to change now the encoder number 2. The encoder axis is going to be 2. Encoder enable is going to be on. The average value is going to be 10. Master is going to be 1. And the Ethernet master encoder is going to be 2. Now we need to cycle power again in order to take effect. We're going to select the robot controller number 1. We're going to go back to the encoder and we're going to select encoder number 1. So the next step, we need to verify that the values on the infeed and outfeed conveyor encoder are getting updated in here on the current count, and also that the current count on the robot controller number 1 is the same as the one that we have in the robot controller number 2. For that, we're going to select over here, and you're going to see that we have a control window where we can select the conveyors. We're going to select the infeed conveyor. We're going to change the speed. And you're going to see the line in here is going to start moving. This line is the tracking frame for the infeed conveyor. So we're going to press forward, and you're going to see that the infeed conveyor start moving. We're going to go back to the teach pendant, and you're going to see that the current count is updating with the value from the encoder on the infeed conveyor. We're going to take note of this value, and this value should match the one that we have on the robot controller number 2. But first, we're going to select the outfeed conveyor. The current count is 1. Over here, we're going to select the outfeed conveyor. We're going to change the speed. And we're going to move the outfeed conveyor. And we can see that the pulse count is updating for the encoder number 2. So now that we have the values for the encoder number 1 and the encoder number 2, we can go to the robot controller number 2 and we should have the same values. We're going to select the encoders. Encoder number 1, we have this value, and on encoder number 2, we have the same value for the outfeed conveyor. So with this, we have finished the configuration for the encoders on the infeed and outfeed conveyor for Robot 1 and Robot 2. We're going to go back to the iRPickTool setup workflow. Our next step is finally getting into the setup for the iRPickTool, and we're going to start by setting up the iRPickTool objects. For now, I just want to give you an overview of how the iRPickTool objects look like. On this diagram, we have on the left the layout of the workcell, where we have the infeed conveyor. We're going to have a sensor for the infeed conveyor that could be a camera, and we're going to have the conveyor station number 1 and the conveyor station number 2. We're going to have the robot, the master and the slave, robot number 1 and robot number 2, that they're going to be picking up the parts for the infeed conveyor. And in this case, they're just showing a fixed station where they are pressing the parts. But in our case, this will be replaced by the outfeed conveyor. One thing that you're going to see, that there is a conveyor station for the infeed and the outfeed of the fixed station for each one of the robots. And also there is a robot object station associated with each one of the robots. And we're going to explain that later. On the right, you can see the preview that you're going to have on the iRPickTool. Each one of the elements that you see here is called an object. You're going to have a parent object that's going to be the workcell as a whole. And this is going to have children objects. You're going to have the gripper, robots, trays, conveyor, etc. And each one of them has also children objects associated with them. So in the case of the iRPickTool Basic, you're not going to see the gripper object. This is only enabled for the iRPickTool. And on the gripper, you're going to configure each one of the grippers that you have on the robot, and also if you have any zones associated with the gripper. Then you're going to have the robots. It's going to be, in our case, robot number 1 and robot number 2. Eventually, you can have a tray, and you can configure the trays that is showing over here. And you're going to have the conveyors. You're going to have the infeed conveyors and the outfeed conveyors, or you can have a fixed station. And inside of each one of the conveyors, you're going to have sensors, and you're going to have the conveyor station. Once you configure the conveyor station, immediately it's going to give you the robot operation conveyor station. So setting up all these iRPickTool objects is going to take easily half an hour or more for a video. So we're going to start the part number 3 of the video over here, and we're going to continue fresh setting up the iRPickTool objects on the next video. It's going to be part number 4. To summarize, on this video we covered the setup for the robot ring using RIPE, that stands for ROS Interface Packet over Ethernet. This setup is required because we need to send the infeed and outfeed conveyor encoder pulse counts from the master robot controller to the slaves, plus the rest of the communication that we're going to have once we set up the iRPickTool objects. Also, we set up the encoders, and we verified that the encoder counts are getting updated on the master robot controller and the slave robot controller with the same values. This is critical because, as we're going to see later, the setup of the tracking frame on the infeed and the outfeed conveyor and the tracking frame for the vision system depend entirely on the accurate value for the encoder counts. I'm going to conclude this part of the video over here. I hope I don't lose you and you're still tuned for the next video. Thank you for watching.